Okay, now we're going to talk about the octal numbering system. We've talked about going from decimal to binary, binary decimal, how to add and subtract binary numbers. Now we're going to talk about the octal numbering system. In the beginning days of computer programming, many things were done in the binary numbering system. One of my first jobs when I worked for the government, I had to learn the binary system because I flipped switches and loaded numbers into a computer using the binary system. Each binary number represented a command or it represented data, things like that. Well, what they found was trying to remember 8 binary digits were too many to remember, and sometimes there were 16 of them. Sometimes we had 2 bytes, or 2 bytes. So 8 binary digits too many to remember. And so what they did was they progressed on from the binary numbering system to the octal numbering system. The octal numbering system is based on 8 digits. It goes from 0 through 7. There is no 8. So once you get past 7, it goes 1, 0, 1, 1, 1, 2, so on and so forth. And this is known as base 8. The octal numbering system. And again, no other symbols are available. So if we want something greater than 7, we have to take them from the same pool of numbers. And they're placed in columns just like the decimal and binary. So basically it works on the same principle as the other numbering systems. Let me pull this up for a slideshow. Oops. There we go. So we look at the octal numbering system, and the far right corner is 8 to the 0. Again, since it's base 8, we go up by 8. The next column is 8 to the first. Next column is 8 squared. Another column will be 8 cubed. And remember, 8 squared is just 8 times 8. 8 cubed is 8 times 8 times 8. So on and so forth. So every time we move to the left, we go up by a factor of 8. So here's just converting from octal to decimal. So we have a number 15, which is an octal. Well, we take the 1, and it's 1 times 8 to the first. And then we add 5 times 8 to the 0. Well, 1 times 8 to the first is 8, and 5 times 8 to the 0, anything to the 0 power is 1, is 5. So this becomes 13 in decimal. We have 234. That's 2 times 8 to the squared, 3 times 8 to the first, 4 times 8 to the 0. 8 squared is 64, so that's 2 times 64. 8 to the first is just 8, 3 times 8. 8 to the 0 is 1, so 4 times 1. So this becomes 128, 2 times 64 is 128, plus 24, plus 4, and equals 156. In decimal. So let's try converting some of the following numbers from octal to decimal. Now the first one is easy, 5 in the 8. Why is it easy? Because the first 8 digits, if you include 0, are the same in decimal as they are in octal. So 5 to the 8th is just, let's see, here we go, 5 decimal. Because if we look, let's just number them, 0, 1, here is the powers of 8, or the 8 base 8, and here's base 10. I should label these at the top. This is base 8, base 10. And I can go from here, I can say, if I want to. But if you look, from here to here, they're exactly the same. It isn't until we get to base 10-8 or base 8-10 that they start changing. So 5 in base 8, or octal, is 5 in decimal. So let's just check us. Yep, that's correct. So now let's erase this so I can use it again. is white space. So the next one, we have 25. Okay, so now we'll have to do a little calculation. So 25. First thing we have is, we have 2 times 10. Whoops, I'm sorry, not 10. Excuse me, 8 to the 0, 1. Plus 5 times 8 to the 0. Well, 2 times 8 is 16 plus 5. And so this equals 21 in base 10. See if we're correct. Yeah, we are. Okay. So far, so good. Erase this. And let's get the next one. 100 base 8. Okay. Again, it's just the same thing. What we want to do is say 1 times 8, 0, 1, 2 squared plus 0 times 8 to the first plus 0 times 8 to the 0 power. 1 times 8 squared is 64. So 1 times 64 is 64. Plus 8 times 0 is 0. Plus 0 times 1 is 0. So this is 64 in base 10. Again, we'll check it. Yep, correct. Okay. Erase this one. Okay, come on. Here we go. Okay, is there another one? Yeah, there's 1, 1, 1. Okay. So, 1, 1, 1. We start with 1 times 8 squared plus 1 times 8 to the first power plus 1 times 8 to the 0 power. Well, 8 squared is 64, so we have 1 times 64 plus 1 times 8 plus 1 times 1. Okay, 1 times 64, 64. 1 times 8, 8. 1 times 1, 1. So this will equal 73 in base 10. Let's check that. Okay, it's correct. So that's how we convert from base 8 to base 10. Again, the same principle as when we went from binary to decimal. Now, we can also convert from decimal to octal. It's a little more complicated. So first thing we want to do is convert 98 to octal. So we list the powers of 8. So we have 8 to the 0, which is 1, 8 to the first, which is 8, 8 squared, which is 64, 8 cubed is 512, and so on and so forth. And let's see, give me a pin here. Just again, to reiterate, 8 squared is just 8 times 8. 8 cubed is 8 times 8 times 8. 8 to the first is 8, and 8 to the 0, anything to the 0 is always 1. So we don't need any power of 8 larger than the original number. So the original number is 98. We really don't need 8 cubed. So we can disregard that. So what we want to do is divide the decimal number by the largest power of 8 and obtain the remainder. So right now, if we look at 98, we divide it by 64. And we can only do that once. 64 only goes into 98 one time. So the first digit is 1. We subtract off what remains. The remainder is 34. So we divide the remainder by the next power of 8 and obtain the remainder. Okay, the next power of 8 is 8. Well, 8 can go into 34 4 times. 8 times 4 is 32. So the second digit is a 4. So we just subtract 34 minus 32 and we get 2. Well, the next power of 8 is 8 to the 0, which is 1. 2 divided by 1 is equal to 2. So the third digit's a 2. 2 minus 2 to 8 to the first 0 power, which is 1, is just 2. So it's 2 minus 2, which equals 0. So our number becomes 98 decimal is 142 octal. So again, it's very similar to the way we did in decimal and binary, but there is a simpler way of doing it. And here, remember, this is what I showed you earlier. Any number less than 8 in the decimal numbering system is the same number as the octal numbering system. But, okay, let's see, I didn't want to do that yet. Okay, we'll do this first. Convert the following decimal number to octal. Okay, so we have 4 in the decimal numbering system. 4 in the decimal numbering system, as you saw, was 4 in the octal numbering system. So now we have 17. Okay, so we have 17, and let's just put it here. We know 8 to the 0 is 1. 8 to the 1 is 8. 8 squared is 64. And 8 cubed is 512. We'll stop there because I don't think I go higher than that. Okay, so we have 17. So we are going to skip the 64. It's too high, but we do have an 8. So we have 17 divided by 8. And the first number is 2. And it gives me a 16. 1 left. Okay, 8 to the 0 power, which is 1. So now I have over here 1 divided by 1 is 1. So 1 times 1 is 1, gives me 0. So it should be 21 octal. Okay, correct. Now one of the things just to remember is the octal number will always be larger than the decimal number. So if you get a number that's less than, you did something wrong. So we'll erase this over here. Okay, the next one, 33. Okay, 33. Well, we know we can skip the 8 squared, so we'll start with the 8. 33, 8. Now, first thing I see here is a 4. 4 times 8 is 32. Remainder 1. Okay, so now I want to do a remainder 1 with just a 1. And it's a 1. It gives me 0. So I get 41 octal. Okay, correct. And let's erase this. Oh, that was the last one. Okay. But what I was saying, there's an easier way of doing it. We can convert the decimal number to a binary number, and then we group the binary numbers in groups of 3, starting from the right. And then we just convert the 3-digit binary number to its octal equivalent. So, for example, and here we have the octal equivalent, 0, 1, 2, 3, 4, 5, 6, 7. And this is all I need to know because anything above that I start using the same symbols over again. So here we have 121. I can convert this to binary, which is 0111, 1001, and that's in binary. And now group them in 3. So I start from the right, 1, 2, 3, 1, 2, 3. So I get 100, 111, 10. And so if I look at that, 001, I look at my little cheat sheet here is a 1. So that's a 1. 111, cheat sheet says 7. And 01 again is a 1. We just pretend there's another 0 there. So I get 171. And that's my octal. So that's a very quick and easy way of doing it, converting from decimal to binary. Either way you want to do it is fine. Both ways work. And yep, that's it for this video. There's one more video, and it'll be doing hexadecimal or hex. Thanks for watching.